Dear students, welcome. This is the fourth module of magnetic effects of electric current. In this module, we discussed about Fleming's left-hand rule and electric motor. At the end of this module, you can state and use Fleming's left-hand rule and to find out the direction of force produced in a given situation. And also you can explain the working principle of electric motor. In our last class, we discussed the displacement of the rod is largest when the direction of current is at right angles to the direction of the magnetic field. So, how can we find out the direction of force on the conductor? We can use a simple rule to find out the direction of the force on the conductor, that is Fleming's left hand rule. This figure gives an idea about holding of hands while using this rule in different directions of current and magnetic field. According to this rule, stretch the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular as shown in the figure. If the first finger, that is the forefinger, points in the direction of magnetic field and the second finger, that is the middle finger, in the direction of current, then the thumb will points in the direction of motion or the force acting on the conductor. Students, this figure we discussed in our last class. Here the current carrying conductor placed perpendicular to the magnetic field. So you can place your left hand like this. Here magnetic field is the direction of our forefinger and direction of current represent middle finger and thumb shows the direction of force. How can we increase the force on a current carrying conductor in a magnetic field? The force on a current carrying conductor in a magnetic field is increased by increasing the current flowing through the conductor, and the second method is by increasing the magnetic field strength, and also the third one is by increasing the length of the conductor. That means F is proportional to strength of the magnetic field B, F is proportional to current I and F is proportional to length L. So F is proportional to BIL. We multiply a proportionality constant K here. So F is equal to KBIL. Suppose K is equal to 1, F equal to BIL. So from this equation we can find out the equation of B here, which is equal to F by IL. So what is the SI unit of this magnetic field strength, which is equal to Newton per ampere meter, or otherwise we can say that the SI unit of magnetic field strength is Tesla. It has another unit, that is Weber per meter square. Devices that use current carrying conductor and magnetic fields includes electric motor, electric generator, loudspeaker, microphones, etc. Today we are going to discussing about working of electric motor. An electric motor is a rotating device that converts electrical energy to mechanical energy. An electric motor consists of a rectangular coil that is placed between two poles of a magnetic field as shown in the figure. In this figure, the blue and pink sides are perpendicular to the magnetic field. That means it experiences a maximum force, but the orange side is in parallel. There is no force. Then we are applying the Fleming's left hand rule. You can see that the force experienced by the pink side is upward and blue side is downward. So this causes the upward motion of pink side and downward motion of blue side. So it helps the rectangular coil to rotate in the magnetic field. In this figure you can observe that after half rotation the orange side is perpendicular to the magnetic field, but you can see that the direction of force there, that is out of the magnetic field. That means it do not affect the rotation of that rectangular coil because the force is in opposite direction. It is cancel out. This figure shows a simple electric motor. It consists of a rectangular coil placed in a magnetic field. a split rings are connected at the end of this coil, it can turn freely. There is a gap between this blue and pink ring, so it is called split rings. Then two purple colored carbon brushes touches to the ring. These carbon brushes are conducting brushes and it connected to a battery. When the battery is on, the current flowing through the coil. The direction of current is pink to blue side as shown in the figure, and direction of force is in pink side is upward and blue side is downward because of Fleming's left hand rule. After a half rotation, you can observe that the conducting carbon brushes touches the gaps between the rings. This time our connection is disconnected. But due to inertia of motion, pink side is moving a little bit forward. At this time, the carbon brushes again touch the split rings. So the current is again starts to flow, but this time the direction of current flow is blue to pink, and that means the direction of current is reverses. Now the direction of flow of current is blue to pink as shown in the figure. So this time blue side experience upward force and pink side experience a downward force according to Fleming's left hand rule. Each and every half rotation the flow of current reverses and it helps the coil to rotate continuously in a magnetic field. Here you can observe that the direction of rotation is clockwise. What happens when we interchange the poles of the magnet? You can observe that this time the pink side, or in this figure the side AB, experience a downward force and CD experience a upward force. The way of using Fleming's left hand rule for side AB as shown in the figure. In side CD you can try yourself. You can observe that the direction of force is in upward direction. After a half rotation, side CD experience a downward force and side AB experience a upward force because of reversing of current. This is causes due to the split rings. So the coil is rotating continuously in anti-clockwise direction. So the direction of rotation depends on the poles of the magnet. So, an electric motor is a rotating device that converts electrical energy to mechanical energy. An electric motor consists of a rectangular coil ABCD of insulated copper wire. The coil is placed between the two poles of a magnetic field such that the arms AB and CD are perpendicular to the direction of the magnetic field. The ends of the coil are connected to the two brushes P and Q of a split rings. The inner sides of these halves are insulated and attached to an axle in the external conducting edges of P and Q touch two conducting stationary brushes X and Y as shown in the figure. This figure is actually given in your textbook. The working of electric motor is already explained in previous slides, so the same thing is repeating here. So please read this slide carefully. You will get the same points we discussed before. I already told you the reversing of current causes the continuous rotation of this rectangular coil. A device that reverses the direction of flow of current through a circuit is called a commutator. In electric motors, the split rings act as a commutator. The reversal of current also reverses the direction of force acting on the two arms AB and CD. The reversing of the current is repeated at each half rotation, giving rise to a continuous rotation of the coil and to the axle. The commercial motors use an electromagnet in place of a permanent magnet. Large number of turns of the conducting wire in the current carrying coil and a soft iron core on which the coil is wound. The soft iron core on which the coil is wound plus the coils is called an armature. This enhances the power of the motor. Students, today we discussed about Fleming's left hand rule and working principle of electric motor. Hope you understood this lesson. Read your textbook thoroughly and watch this video carefully. Thank you.